All right, so now we are talking about confidence intervals for means, and this formula is going to look very similar. We're going to do x bar plus and minus z times, and then this is where this one just kind of changes a little bit, and it's going to be just like we did with the sample distribution, it's going to be the sigma divided by the square root of n. Okay, so that's going to be the whole formula to find a confidence interval. This is going to be, again, it's the sample mean, right? It's like a point estimate. That's going to be the z-score for the confidence level. That's going to be our sample standard deviation and our sample size, of course. Okay, so this idea, we can actually just use our calculator to find this value and this value, and then we've already kind of listed a couple of key values for the z-scores. So let's just make an example. Let's see if the book uses a good one. We're not going to go into that distribution. Okay, right here on the first page. So let's use table 2, which apparently cannot be seen. Whoops. Okay. Might be small, but there's table 2. So I'm going to use these numbers, okay, and we're going to create, let's say, a 95% confidence interval for the actual, what is this? This is the miles per gallon of 2011 Ford Focus vehicles. Okay, so they sampled 16 different car owners, and they got these miles per gallons that were reported by those drivers. And we're going to estimate a 95% confidence interval based on that data. So here's what I'm going to do. I'm going to go to my calculator. And the first thing I'm going to do is I'm going to go to Stat Edit. And I'm going to put the data into my calculator. So I'm just going to go ahead and input these values. And that might be tedious, but also make sure we don't make any errors like I was about to do. Now, that was an error as well. Now the other option is you could just add up all of these values and divide by the total, right? Because we're just finding the average. But we also need to know the sample standard deviation. So for that, it's a lot easier to use the calculator anyway. So I suggest just plugging it in right away, hitting Stat, going to Calc, and doing the 1var stats. Okay, the data is in L1. There is no frequency data. So we'll just hit calculate. And now we have the information we need. So X bar is now 36. Oops. 36.8, and the sample standard deviation is 2.82 approximately. So I got that straight from the calculator. So now we just plug it into our formula, right? Since we're talking about a 95% confidence interval, the z-score is 1.96. And we know our n is 16, right? So we have all four things to plug into this formula. So we do 36.8 plus and minus 1.96 times 2.82 divided by the square root of 16. So 1.96 times 2.82 divided by square root of 16. Whoops. And so I get 1.3818 is the value I'm going to be adding and subtracting. So 36.8 plus that, and 36.8 minus that. And there's my interval. And so we're 95% confident that the actual MPG, miles per gallon, for the 2011 Ford Focus is between 38 point, we'll just round these. Oops, let me start with the smallest value, 35.4 to 38.2 miles per gallon. And that is essentially the whole thing, right? We can just change the data. The data will affect X bar and sigma. So it'll affect our sample mean, sample standard deviation, and the sample size, obviously. And our confidence level corresponds to the z-score, same way. Don't forget, if they do ask for a weird confidence, well, not a weird, but a different confidence interval. So let's say we wanted a 92% confidence interval. We would have to think back to what that means in terms of the curve, right? And so 92% inside, 4%, 8% outside, 4% is on the left side. And so we would have to then, go to our inverse norm and do a 0.04 to find the actual. So for a 92% confidence interval would be a z-score of 1.75. Right? Okay, good to know, I guess. But that's how we would find any z-score for any confidence level. Okay, and then same, I think we're going to talk about how to find the sample size. So again, because we have a different formula to find sample size, there's going to be a slightly different formula for that as well. So that's going to be So n equals, it's going to be z times s over margin of error squared. So let's take a look at an example here, example 5. So we again consider the problem of estimating the miles per gallon of a 2011 Ford Focus. How large a sample is required to estimate the mean miles per gallon within 0.5 miles per gallon with a 95% confidence interval. So we're given the same data, okay? Right, we still obtain a sample data because we have to have those numbers to work with. But if we wanted to, use that to then come up with a more accurate sample size, this is what we would be looking at. So for 95% confidence level, 1.96, the standard deviation there was 2.92. So we're multiplying those, dividing by, if we want to be within 0.5 miles per gallon, we're dividing by 0.5, and then we're squaring this whole thing. Right, and the book says that comes out to be 131.02. If you ever get, when finding a sample size, if you ever get a decimal, you actually have to round up, right? So regardless of what this decimal is, you have to go up to the next one, because if I need 131.02 people to get this margin of error, if I say only 131, that's not quite enough to get the margin of error. So I have to always round up when dealing with sample sizes. So I'd say 132 people. Okay? And that is it for this section. So it's very similar to the last section. Same concepts, same ideas, except now we're talking about means. We're talking about averages. And so our formula changes a little bit because we're now using the sample distribution for means. So we're using the sample standard deviation and the sample size. Okay. Yeah. Then that's about it. So I will see you guys next time.